Between 1942 and 1946, top-secret development was undertaken on the British supersonic aircraft, the M.52. This bullet-shaped plane with razor-sharp wings was designed to fly at an incredible speed of 1,000 miles per hour. Design of the M.52 took place at Miles Aircraft Limited, an aeroplane manufacturer known for aircraft like the Miles Messenger, the Miles Master, and the Miles Martinet. The company was headed by the unique duo of brothers Fred and George Miles, with the help of Fred's wife Blossom.
Both Freddie and George had that streak of innovation. I think really this was the hallmark of everything that happened at Miles. And Blossom, I think, sometimes just tempered them down to reality now and then.
George Miles, the chief technical director and designer at Miles Aircraft, was known for highly imaginative designs like the tandem wing M39 Libellula, an experimental aircraft meant to meet the Air Ministry's specifications for a high-speed and altitude bomber. In 1944, George Miles came up with the idea of creating an inexpensive, multi-purpose aircraft, which could be used as a military freighter on unprepared airfields or as an air ambulance or flying hospital in the Burma campaign. He recognized that such a transport would be a hot commodity in the civilian market when World War II came to a close. This aircraft would be known as the Aerovan.
Well, just towards the end of the war, there was obviously a lot of concentration on the transition from military projects to civilian aircraft. And my uncle George had a very imaginative approach to aeroplane design. And he reckoned that a small one-ton freighter would be needed all over the world for carrying loads by air, the sort of things that are carried by one-ton trucks by road.
The twin-engined aircraft with tricycle landing gear was largely made of wood. There was a single wooden spar, and the pod-like fuselage was made of plastic-bonded plywood. At the back of the plane, the large hinged door and high tail made the Aerovan easy to load and unload. The interior of the pod could be configured in a number of ways depending on the end use of the Aerovan.
The Aerovan was designed with this pod-type fuselage to be a multi-purpose aircraft. You could equip it with seats and turn it into a 12-seater passenger aeroplane. Take the seats out and it becomes a one-ton freighter. You could drive a car into it and use it as a car transporter, or it could take just ordinary freight in packing cases.
One of the innovative features of the Aerovan was how low it was to the ground. The aircraft's sill was at 2 feet, allowing for easy loading and unloading, thus giving the Aerovan an edge over most of the transports of the era.
Ordinary aeroplanes are inconvenient, or were at that time, for loading, because you're having to load through a side door, high off the ground, probably with a tailwheel aeroplane like a Dakota, which is at an awkward angle. So he concluded that the Aerovan, which simply consists of a pod, a one-ton pod, with a cockpit stuck on the front, some wings up above it, and the tailplane on a boom high over the rear end of the fuselage, rear opening doors with the sill of the floor relatively close to the ground, so that a simple ramp allowed you to load the aircraft quite easily.
In many ways, the Aerovan was similar to an early German design by Wilhelm van Ness, the Arado 232 or Millipede. This rear-loading aircraft, unveiled in 1941, also had a box-like fuselage, high tail and high wing, all features which made it an ideal cargo craft. Unlike the Aerovan, the millipede had a set of 10 small non-retractable wheels on each side, which allowed the aircraft to operate even lower to the ground, as well as on soft or rough terrain. It's uncertain if George Miles was inspired at all by Van Ness's design, or if it was a case of two designers stumbling upon similar solutions while working in isolation. George Miles did, however, borrow from one of his own designs, the Miles Messenger, to allow the Aerovan to take off and land from shorter runways. The external aerofoil flaps on both aircraft helped to produce high lift and low drag. This allowed the Messenger and Aerovan to easily operate from short, impromptu runways during wartime conditions or in an emergency. With the prototype complete, the Aerovan first took flight on January 26, 1945, piloted by Miles Aircraft's chief test pilot, Tommy Rose.
I'm told that it was quite pleasant to fly, short takeoff and short landing, not particularly fast, and generally handled reasonably well.
As a little airplane to fly, it was very pleasant, and the cargo didn't seem to affect the centre of gravity too much. It had quite a wide centre of gravity, which is important if you're going to have that type of machine. Little engines, but quite reliable.
The success of the Aerovan's prototype prompted the Miles brothers to begin construction of 2 more aircraft. However, the Air Ministry did not share their enthusiasm.
The prototype was built, as sometimes happened with Miles Aircraft, without the Ministry of Aviation or Ministry of Aircraft Production's approval.
The brothers were reprimanded by the Air Ministry and received a note from the minister for building the Aerovan prototypes without permission. The United Kingdom had made an agreement with the United States in 1942 to split the manufacture of multi-engined aircraft. The United States would focus on transports, and the United Kingdom would focus on bombers. By building a transport, Miles Aircraft had put the Air Ministry in an uncomfortable political position. All work was halted on the Aerovan, and the project remained mothballed for the next 6 months. By mid-1945, the war was over in Europe. Suddenly, civilian transports were in high demand as Europe started to rebuild itself. Having focused on bomber production, the UK had to rely heavily upon American-made aircraft to move cargo and passengers. Development was allowed to resume on the Aerovan, but the Air Ministry-imposed delay had made it difficult for Miles to keep up with their orders. The Aerovan would be sold to civilian operators all over the world, including Angola, Belgium, France, Iraq, Kenya, Turkey, and the UK.
It was really quite successful. It went into production after the war, and some 50 or more were built and sold to a variety of companies, some of whom were running feeder line and freight aircraft operations. They were sold into the Middle East. They also were used for aerial surveying, because a steady, relatively slow-flying aeroplane and to mount cameras through the floor for aerial survey was really quite easy.
Though the Aerovan proved a popular aircraft, the Miles company was facing a hard time transitioning to a peacetime economy. The advanced M.52 Supersonic project had been cancelled when the first prototype was 82% complete. The exact reason for the cancellation remains unclear, but it was a terrible blow to the company. Having the world's first supersonic aircraft would have been a boon to the fortunes of Miles Aircraft. There were additional delays in civil production because priority during the war was given to the construction of the M33 Monitor, an aircraft contract cancelled by the Air Ministry after the first few aircraft were delivered. Production continued on the Aerovan in these trying times. Though the aircraft was purchased by operators from around the world, it was not without flaws. Some worried about the airplane's flying ability should it lose an engine.
We tested it on single engine work, but without a load. And my estimate would be that if you had max load aboard and lost an engine, you'd be very hard pushed to maintain height.
Though some fault the Aerovan for not being able to fly level with a full load should an engine fail, other twin-engined aircraft of the era like the Oxford or Anson had the same problem. But the Aerovan had a low sink rate, allowing for a smoother landing under such conditions. Though the Aerovan had many features which made it a desirable transport, it couldn't compete with larger freighters in terms of its cargo capacity.
It had potential, but it was too tiny. I mean, the only cargo it could reasonably carry was one motor car. Now, that is, in my opinion, too limited to offer an extensive market. And I think this is where it foundered.
George Miles recognized the cargo limitations of the original Aerovan. He had already designed a 4-engine transport called the Miles Marathon, and he came up with the idea of grafting the wings of the Marathon onto the Aerovan. The new, more powerful aircraft would be known as the M.51 Merchantman.
A 2-ton version of the aeroplane was developed, the Merchantman, which had 4 engines, obviously needing more power for 2 tons. The prototype was built and flew successfully.
In cargo mode, the Merchantman could carry up to 5,000 pounds, while in passenger mode, it could carry 20 people in 5 rows of 4. The Merchantman got its extra power from 4 250 horsepower de Havilland Gypsy Queen inverted inline motors, mounted on the underside of its wings. The Merchantman was not the only attempt by George Miles to improve the Aerovan. The Aerovan was designed for the easy loading and unloading of cargo. But was there a way of making the process even more efficient? George Miles' innovative M68 Boxcar attempted to do just that. This innovative aircraft had a detachable cargo section that could be towed to and from the main aircraft.
In the Boxcar, the fuselage of the Aerovan was made detachable, and there it became a boxcar freighter. The tail fairing then fixed straight onto the back of the cockpit, so that the aircraft, looking a bit like a tadpole, could fly back to pick up the next freight container. That was perhaps a precursor to the container freight operations which are now ubiquitous throughout the world.
The Boxcar flew in August of 1947, powered by 4 90-horsepower Blackburn Cirrus Minor 2 engines. In all, it could carry 1,600 pounds of freight. The M68 Boxcar didn't go into production, but a similar American design came out just 3 years later, the Fairchild XC-120 pack plane. Like the Boxcar, the pack plane had removable cargo pods that could be attached and detached from the fuselage. Only one pack plane was built, and it was tested extensively, but it never made it to production. As innovative as the designs of George Miles were, the company struggled economically. In the winter of 1946-47, Miles Aircraft Limited had slim financial reserves, and they had to contend with a frigid winter and England's poor power-generating system.
The Aerovan went into production, but that was at a time when the economy was in difficult straits. The 1947 winter was really very, very bad. There were fuel shortages, everybody was on a 3-day week, and also at the same time, Blackburn Aircraft had problems with the crankshafts of their engines, and they ceased deliveries for about 6 months. The production and sale of aeroplanes was not easy. Easy to take the orders, less easy to deliver the aeroplanes.
Power outages regularly halted production. In addition, they couldn't heat the factory consistently, a great problem as many aircraft were made out of wood bonded with glue. Miles Aircraft sought and received emergency assistance from lenders to continue operation, but the company's finances spiraled out of control. Miles Aircraft Limited went into receivership and its aviation assets were purchased by Hanley Page. The Aerovan, Boxcar and Merchantman aircraft were all cancelled. The Aerovan, Boxcar and Merchantman aircraft were all cancelled. But the Miles family were not deterred by the financial failure of Miles Aircraft Limited, and by the end of 1951, the brothers and Blossom were all back in business as F.G. Miles Limited. They had been able to pay off their creditors with profits from two of their side businesses, the manufacture of the copycat office duplicating machine and the biro pen. The biro, invented by Laszlo Biro, could write at high altitude, and it seemed like a smart wartime investment, as it was a simple tool that could be readily used by the RAF. However, when Fred Miles offered to produce it for the RAF, government officials refused on the grounds that it would distract from aircraft manufacture. Fred Miles ultimately pushed through the biro by arranging with the Ministry of Labour to permit 17 unskilled girls at the Miles Aircraft Works to assemble the pens. Back in the aircraft business, the trio sought to resurrect the Aerovan. They believed it was too good an idea to abandon. In the 1950s, the Miles brothers teamed up with the French aviation firm Hurel-Dubois to revitalize the Aerovan concept.
Later on, in the mid-50s, mid-1950s, my father formed a joint company with the Hurel-Dubois aircraft company in France. They specialized in passenger and freight aircraft using a high aspect ratio wing, like a glider's wing, long and thin, which is very much more efficient than the normal type of wing. And my father and my uncle were attracted to this concept as providing better performance. So, in conjunction with Hurel-Dubois, they converted a standard Aerovan by fitting a high aspect ratio wing built on the Hurel-Dubois design, and it became the HDM 105.
The HDM 105 was built at Shoreham and flew in March of 1957. It was showcased to the world for the first time at the Le Bourget Air Show.
My father and mother and my uncle and aunt were present at Le Bourget with the aeroplane, and there in the crowd you can see them moving around and talking to people, whilst later on the aircraft does a flying display in the hands of the test pilot in hope of gaining orders for the HDM 105 version of the Aerovan.
One company interested in cargo planes at the time was Short Brothers and Harland. In the 1950s, they began preliminary studies which would be used ultimately to aid in the construction of the freighter, the Short Belfast. Fred Miles approached Short Brothers to see if they would be interested in collaborating on the HDM 106, a production version of the HDM 105. After careful scrutiny, Short Brothers agreed to purchase the design and were satisfied with the general concept. However, in the end, they rejected the HDM 106 and created their own short SC-7 Skyvan. Like the Aerovan, it had a high wing and tail, rear loading doors, and a low sill to allow for easy loading and unloading. Unlike George Miles's design, the Skyvan was of all-metal construction and could carry over double the cargo weight. It first flew in January of 1963, and production continued for the next 20 years. George Miles's original vision for the Aerovan does not live on just in the Skyvan. His basic concept can still be seen in many other transports.
The aeroplane was really quite successful, and in fact was the precursor to the majority of freight-type aeroplanes ever since. The Blackburn Beverly, big four-engined Air Force freighter, looks almost the same as an Aerovan, although about 10 times the size. When you look at the C-130 Hercules, although it hasn't got a boom carrying the tail, when its doors are open, side view, it looks very much the same. The concept is certainly the same, of a low-slung aeroplane, short takeoff and landing, with a loading ramp from the rear. And that has governed the design of that type of aircraft ever since, all over the world.
The Aerovan was conceived by George Miles to facilitate the efficient transport of small cargo over a short distance. Though the Aerovan was sold around the world, it was not the financial success that the Miles brothers had hoped for. As well, its variants like the Boxcar, Merchantman, and HDM 105 never made it to production phase. Had Miles Aircraft Limited not been slowed down by bureaucratic red tape and a difficult post-war economy, perhaps the Aerovan might have carved a bigger niche for itself in the marketplace. Short brothers were able to build upon the Aerovan concept to create the short Skyvan. Also, remarkably modern transports like the C-130 still share some basic attributes of the Aerovan. An aircraft built by the Miles brothers 70 years earlier, using only the basic materials available at the time and their boundless imagination. As Nazi Germany and Britain dueled for air superiority, aircraft designers rushed to get their fledgling jet fighters operational. The RAF's Gloucester Meteor became the world's first jet to go into service in July 1944, the same month that the Messerschmitt Me-262 was just beginning its trials.
The 262 looked like a deadly shark. To me, it exuded power. The engines looked quite big, underslung on the wings, and you looked at the nose, which was very sharp, with 4 30mm cannon in, and you knew this is a deadly punch. And altogether, if you wanted to use one word to describe the aircraft, I would say lethal. At that time, the top Allied aircraft, performance-wise, had a top speed of 446 miles an hour, and when I tested the Me-262 at Farnborough, we had a top speed of 568 miles an hour. 125 miles an hour faster than the fastest Allied fighter.
The Messerschmitt Me-262 revealed the future of aerial warfare, in which high-speed jet fighters would dominate the skies. Although very quick, the 262 could not fly supersonic, but the race to fly fastest was on. Early in 1943, the RAF received an alarming intelligence report. A German prisoner disclosed that work had started on a new aircraft with a top speed of an incredible 1,000 miles an hour, faster than the speed of sound. To counter this supersonic threat, the government turned to Frank Whittle, a visionary inventor serving in the RAF, and the designer of Britain's first jet engine.
Frank, like so many geniuses, he had a fixation of what he was after, and that was to achieve ascendancy for Britain in jet flight. He felt, and quite rightly so, that he was the right man to lead it along this path.
When Father was a cadet at Cranwell College, he began to think about alternatives to the piston engine and propeller combination. So whilst he was still a cadet there, he wrote his final thesis at the end of the 4th term and entitled it Future Developments in Aircraft Design. And in this thesis, he recommended the turbine as a potential prime mover for aero propulsion, which was pretty far thinking for a young fella. And then suddenly the penny dropped, as he used to say, around October 1929, and he realized jet propulsion. And so he then went through the process of doing all the calculations and even getting round to the scantlings of a proposed engine. So that's how his thinking was going, to rid aviation of the piston engine with its altitude limitations and the propeller with its speed limitations.
Well, we were, of course, doing our transonic testing on piston-engined aircraft. And in April 1944, we took the Spitfire up to the highest Mach number ever achieved with a piston-engined aircraft, Mach 0.92. And the aircraft was virtually destroyed on the pull-out from this, and the pilot was very lucky to escape with his life. And we realized we were at the end of the road, frankly, because a piston-engine aircraft will never achieve supersonic speed because of the drag of the propeller. Now, just as that road seemed closed to us, right on cue, the new vista opened with the jet engine.
The ME-262 had demonstrated that German aviation probably had the capability to develop even faster aircraft. The British intelligence report of a 1,000-mile-an-hour Nazi jet fighter gave Whittle the opportunity to demonstrate his prowess in jet engine design.
There's a lovely painting of the first engine called the Whittle unit. When it was first started up on the 12th of April 1937, it shows him standing by the engine, which had accelerated away out of control when they first tried to start it. But it stopped at 8,000 RPM approximately, and then the engine faded away and stopped, and everybody heaved a sigh of relief. Well, the only person left standing by the airplane was Frank Whittle, because everybody else had fled. And people asked him why he didn't run away, and although he used to say, well, he was rooted to the spot by fear, I think really it was his baby, and he just couldn't leave it. And so he did stand with it until it decelerated and everybody came back.
Frank Whittle's revolutionary jet engine, the W2700, would need enough thrust to punch a plane through the sound barrier. It would be the power plant of a British supersonic aircraft whose goal was to reach a speed of 1,000 miles per hour. The aeroplane was the M.52.
Top there. No idea what that is. It looks like a toast rack.
The company chosen by the Ministry of Aircraft Production to build the supersonic jet was the Miles Aircraft Company. Jeremy Miles was a small boy when his father's firm got the contract.
Presumably that's why they changed that.
Yeah.
That is interesting.
Yeah, quite an early stage.
It is an odd choice to choose a company which had a reputation for making small wooden aeroplanes to develop and build the first supersonic project. But bear in mind that the company, Miles Aircraft, had a reputation for most innovative prototypes. Their background was in racing and in making high-speed trainers.
They were very, very advanced thinkers, there's no doubt about it. No other aircraft company in the country was anything like them. A lot of them were still building biplanes right up to the beginning of the war. Miles had stopped building biplanes in the 1920s.
People were very appreciative of the fact that Miles had this wonderful innovatory streak in them, and that they might come up trumps with something.
At the time, very little was known about supersonic flight. Building an aircraft that could break the sound barrier would require a complete rethink of aircraft design. Leading the team facing this extraordinary challenge was a 25-year-old aerodynamicist named Dennis Bancroft.
Well, it all started on the 9th of October 1943 when F.G. Miles was called up to the ministry and presented with a small piece of paper like this, which says, would he like to, or could he design and produce an aeroplane, another research aeroplane for the ministry. And it was rather odd aircraft. The first requirement is that it should fly at 1,000 miles an hour. And another major requirement is, on this piece of paper, that it shall be flying in 9 months.
9 months?
Well, 9 months is impossible, obviously.
The Miles brothers would never turn down anything. A challenge to them was their way of life. And they seized on it, and their attitude was, well, we'll do our damnedest to achieve it.
Towards the late 30s, my uncle George joined the firm and progressively took over design responsibility for my father, who then was concentrating on the management of the rapidly growing factory. By the time the M.52 came along, George was chief designer, and Dennis Bancroft was the leading light on the design of the M.52.
All the aircraft industry, that knew anything about aeroplanes, thought that the supersonic barrier was impenetrable with modern aircraft.
In 1944, Britain and Germany were in a secret race to build faster planes. With speed came air superiority. The victor would control the skies. Dennis began his quest to go supersonic by looking at the one object that flew faster than the speed of sound, a bullet. In the 19th century, the speed of sound had been recorded during experiments with bullets. In recognition of the Austrian experimenter Ernst Mach, the speed of sound was designated Mach 1, 660 miles an hour at altitude, or 760 miles per hour at sea level.
But of course, a bullet goes from high supersonic speed down through to normal, whereas an aircraft goes from normal up through to so they were going in the opposite direction, which made a complication.
British ballistic researchers advised Dennis that drag could increase by up to 4 times as the aircraft moved from Mach 0.9 to Mach 1.1. On the only surviving blueprint of the M.52, Jeremy Miles discovers how Dennis was modifying the frontal area of the fuselage to reduce drag.
That's interesting. There's signs of a sketch there overlaid on the drawing, more to the bullet shape.
That's right.
On which they had based a lot of the aerodynamics of the aeroplane. That's interesting.
Yeah.
Yes, it's obvious that the air intake hasn't been fully developed at this stage, understandably, because it's an early drawing, because in transonic and supersonic flight, they're going to have to make variable intake so that the airflow can be controlled according to the needs of the engine, regardless of what speed you're doing. It's going to be quite complicated.
In his campaign to keep drag down, Dennis now turned his attention to the wings of the M.52. Dennis took the wing of a Spitfire as his starting point. He worked out that halving the thickness of a Spitfire's wing would quarter the drag. He reduced the drag by half again by giving the wing razor-sharp leading and trailing edges. Finally, by reducing the wing area of a Spitfire by 50%, he was able to cut down drag by half again. In less than a month, Dennis and his team were ready to present their plan to the men from the Ministry of Aircraft Production.
We gave them a GA drawing of our proposed aircraft with its specification of the size and dimensions and performance and all the rest of it, and said, this is what we suggest. We can meet basically your requirement of, we think, of travelling at 1,000 miles an hour. We did say that it wasn't necessary. One thing was that we'd have to use a biconvex wing, and there was absolutely no low-speed information about a biconvex wing as whether how it could fly. So we'd actually made and tested a wing, a biconvex wing, and put it in our wind tunnel, and the figures we got from it at the lower speed of 200 miles an hour or so showed that it looked quite promising.
In December 1943, the ministry awarded Miles Aircraft a £100,000 contract to build the top-secret aircraft. Work on a full-scale mock-up began immediately. To test the biconvex wings, Dennis installed them on a Miles Falcon aircraft. On the shop floor, the wings' sharp leading and trailing edges were an occupational hazard.
People were cutting themselves by pushing the aeroplane around.
That's why it was known as the Gillette Falcon.
Yeah, it really cut people out.
It was so thin.
Flight tests with the specially modified Miles Falcon would reveal if the ultra-thin wings would perform safely at low landing and takeoff speeds. The results demonstrated that the M.52 would be able to operate with biconvex wings. In its brief, the ministry had specified that the M.52 must have an all-moving horizontal stabilizer. From transonic tests with the Spitfire, it was discovered that an all-moving tail is essential for a pilot to maintain control when he approached the speed of sound at Mach 0.83.
They were doing dive tests on the Spitfire and finding out that when you got over about 0.83 on a Spitfire, the elevator failed to work properly, and the aircraft just got in a dive and got out of control.
In other words, you're in a dive and the aircraft is trying to go more and more nose down. The only way you can counteract it is full-blooded physical pull on the stick. Since we reached the limits, there was either we couldn't do much about the physical strength aspect, so the thing to do was improve the effectiveness of the elevator. And we moved from the standard tailplane and elevator onto the all-moving tailplane.
In subsonic flight, moving the elevator produces a change in lift, which tilts the nose up or down. At transonic speeds, the nose and leading edges produce shock waves. Turbulence and buffeting disturbs the air traveling over the stabilizer, rendering the elevator useless. But with an all-moving tailplane, the complete horizontal stabilizer moves, and the surface is large enough to deflect the airflow and enable the pilot to keep the nose up at transonic speeds.
And we put an all-moving biconvex tailplane on the Falcon and flew that one. And so the pilots could do all the tests, and he could prove the aeroplane would take off and land and fly around and had good stalling, well, reasonably good stalling characteristics, nothing severe, and to prove that that was satisfactory.
Although not capable of accurately simulating performance at supersonic speeds, wind tunnel tests with a small-scale model of the M.52 confirmed that Dennis's original layout was aerodynamically on the right track. Wind tunnel tests from a larger 1/6 scale model gave more reliable indications that his design had reduced the M.52's drag to the point that it could fly supersonic. Dennis now believed that the 1,000 mile/hour target set by the ministry was squarely in his sights. Frank Whittle was also making progress on the M.52's specially modified jet engine.
Given the desired thrust to punch a small aircraft like the M.52 through the sound barrier to achieve about 1,000 miles an hour, it was calculated that they would need a thrust, I think, of around 7,000 pounds. And Frank Whittle, Dad, calculated that if he augmented the thrust of the W2700 engine by using an aft fan and afterburning, he could achieve a sufficient level of thrust for this small aircraft to get through the very high Mach drag factor to transit the speed of sound. This is the model of the W2700, which was the engine which was destined to be the power plant for the Miles 52 project. The difference is this is just the straight W2700 engine without the thrust augmenters, the reheat system, which was going to extend the engine down the back. But the principle's the same. The air intake is down here at this end, where the air enters here and here behind, and enters a double-sided centrifugal compressor. The air is accelerated outwards into a diffuser here, where velocity is converted to pressure. Pressure is increased to about 4:1 into these, which are the combustion chambers. Fuel is introduced into the inner lining of the combustion chamber, and the air travels this way, expanding, and then it is directed through 180 degrees through the nozzle guide vanes and through the turbine blades, and then out through the exhaust, giving you jet propulsion.
A prototype of this engine powered the Gloucester Whittle, which made the first flight of a British jet-engined aircraft on May 15th, 1941. By chance, Eric Brown had diverted to RAF Cranwell due to poor weather and witnessed the jet's first flight.
Suddenly out popped an aeroplane with no propeller on it. And I'd never seen a jet airplane in my life, and I didn't really know anything about jet propulsion. And anyway, I watched this with great interest. And it eventually took off about 7 o'clock in the evening. And the screaming noise that it went off at, and I was absolutely intrigued by it. First thing that strikes you as a pilot flying a jet aircraft is the marvellous view you have. There's no big engine sticking out in front of you. Second thing is when you get in there, the total lack of vibration, which you have so much in the piston engine aircraft. And thirdly, the lack of noise. There may be a lot of noise outside, but you're sitting ahead of the jet engine and there's virtually no noise at all. So these were the three big impressions. I think the advent of the jet engine is probably the most significant event that has happened in aviation since the first flight of the Wright brothers.
Jack Whiting was an engineer with the team responsible for increasing the thrust of the Whittle engine to be used in the M.52.
Jim Hodge, the designer of the No. 4 augmenter, showed me his calculations and proved beyond doubt that we would indeed achieve 1,000 miles per hour. I went through his calculations and I have to admit that I couldn't fault them. But at the same time, Frank Whittle did say, "I sometimes have a feeling myself, Jack, that we could choke, but I think we're on the right track."
Whittle was going to give us a jet engine which would be given a huge amount of excess thrust by having, for the first time after burning, sometimes it's called reheat, sometimes it's called augmentation. What it means is you are going to burn raw jet fuel in the jet pipe, and this will give a tremendous amount of excess thrust.
He seemed, when he was talking about it, that he felt confident he could achieve the desired thrust. But of course he wasn't in charge of the airframe, and the problems of the intake, where you've got to reduce the supersonic flow to subsonic at the point where it enters the compressor, that was a little bit of aerodynamics being handled by others, I would say.
Creating the variable air intake required by Whittle's engine and designing the airframe that would cocoon it was a major challenge for Dennis.
The engine itself is a complicated thing, but quite a lot of the engine itself is just a duct, a large duct of about 3 foot 6 in diameter, and it's red hot on the outside and full of these high temperature gases, so you can't put a structural member through it. You can't put anything through the engine. Whittle decided that they wanted the engine as a complete unit to be fitted to the airframe, because you couldn't really get it and service the engine easily because of the airframe being surrounded. So we had to provide the airplane with a hole in the middle, 3'6" in diameter, the aeroplane was then put vertically upwards in a hangar, and the 18-foot odd engine was then dropped down from the top, down inside the engine while the aircraft was vertical, and screwed in place, and then the aeroplane turned up in its normal position.
With the engine filling up so much of the fuselage, there was not much room for fuel, nor the pilot.
It was necessary to have the smallest frontal area possible, so you couldn't really put the pilot anywhere else except right in front of the engine, because if you put it above or below or anything, it would increase the frontal area very considerably in the drag. The pilot needs about the same 4-foot diameter, roughly, 3'6", 4-foot diameter cockpit as a minimum, and you've then got to get air in as well. So you have to have a very small cone, which is obviously the only place is fitted at the front. So that's why he was at the front.
The minuscule cabin meant that Dennis needed to find a test pilot who was no more than 5'6" tall. Fortunately, one of Britain's best test pilots, who had earned the nickname Winkle for his diminutive stature, was short enough to squeeze into the M52's cockpit. But in the event of a critical emergency at supersonic speed, how would Eric Brown escape? Pulling back the canopy and bailing out was not an option at 1,000 miles per hour.
The whole nose of the M52 was an escape module. In the event of an emergency, the pilot could fire 4 explosive bolts, which would disconnect the nose from the fuselage and also project it forward, so it would escape from the main body of the aircraft. And it would then deploy a drogue which would slow up the nose to a speed at which the pilot could then bail out manually from the capsule.
In 1944, the United States became aware of the M52 supersonic project. The Bancrofts recall an official visit to the M52's secure assembly area by a small delegation of American aviation specialists, including a representative from the Bell Aircraft Company. The Americans were also given a demonstration flight of the Falcon, with its biconvex wings and all-flying tail.
We had been instructed to give every detail of the plane and of the project to the Americans, and the drawings, and answer all questions, and they were then going to have us going over there to get all their gen 3 weeks later. But lo and behold, that visit to America was immediately cancelled.
America said that
they said it was too top secret. They couldn't. Everybody thinks it's because they hadn't got anything to give.
Quite. When we talked to them, we found that they knew pretty well nothing about supersonic flight at all. And as Elizabeth says, we think they stopped us from going there because they had nothing there to show us.
Just when Dennis and the M52 team believed they were on the home straight for the first test flight, they learnt that Bell Aircraft had been given the task of building America's contender for the first plane to fly supersonic. The end of the war put the Germans out of the supersonic race. There was a rush amongst the Allies to capture their advanced aircraft designs. It was revealed that unlike the M52's straight wings, German aerodynamicists favoured swept-back wings for their high-speed aircraft. It also surfaced that the typist transcribing the intelligence report had accidentally substituted miles for kilometres. The German prisoner was describing an aircraft that could fly 1,000 kilometres per hour, not 1,000 miles an hour. Germany's DFS rocket-powered reconnaissance aircraft eventually achieved 900 kilometres an hour. Although unfinished at the end of the war, the prototype was taken to the Soviet Union, rebuilt, and achieved the speed. But on its third test flight, the aircraft suddenly stopped responding to the controls. The pilot successfully bailed out, using an escape capsule similar in concept to that of the M52. With Germany's demise, the United States was now the M52's main competitor in the race to break the sound barrier. The American Bell X-1 had moved quickly from blueprint to cutting metal. The X-1 was rolled out of the hangar ahead of its British rival in December 1945. However, Bell was forced to delay test flights for a year because of problems with the rocket engines.
There's no doubt about it. We were the foremost nation in the world. We were ahead of the Germans in transonic testing. And the Americans acknowledged this.
By early 1946, the M52 team were confident that they would win the race to go supersonic. But on the 13th of March, Dennis received a stunning blow.
When news of the cancellation was telephoned to F.G. Miles, I just don't think he could believe it. It just came completely out of the blue and as a total shock. Everybody was shocked.
Sadly, the M52 project was cancelled very abruptly, shortly before the prototype was due to be completed and to start its flight trials. The news apparently came out of the blue. My parents and everybody else working on the project were quite horrified. There were various reasons ostensibly given, one of which was that it was too dangerous to ask test pilots to risk their lives flying a supersonic aeroplane, which had never been done before. That, after all, is what test pilots do.
Without warning, the leading contender to break the sound barrier was scrapped by the Supersonic Committee of the Ministry of Supply and Aircraft Production.
We got a cancellation to stop all work, so all the labour was taken off it and put on other things, so that we just closed the doors and were told that we had to collect all the drawings and photographs and pieces and everything else and put it into this bay, and the ministry would then take it away.
At the time of the cancellation, Dennis had been confident that the M52's first test flight was imminent.
The first aircraft was a few weeks away from its first test flight, and the second aeroplane, the Supersonic, was mostly 6 or 9 months away. But we were so disgusted at that stage to cancel, which we felt was a certain success, or a certain success, so close to completion. Is absolutely crazy.
Dennis and Elizabeth Bancroft suspect that secret British cooperation with the American X-1 project could have been a factor behind the cancellation.
Recently, I've come across an American report in an American archive that says that one of our directors entertained 2 American visitors to the aerodrome at Woodley, I think on the...
July 46?
Yes, in July 1946, which was 6 months afterwards. And the real aeroplane, because they felt it and there was a sharp edge and they had to get underneath it.
And these 2 Americans reported back via their London intelligence headquarters to Wright Field in America.
About a year after the 2 American visitors inspected the M52 at the Miles factory, the Bell X-1 was delivered to Muroc Airfield in California.
It is quite obvious when you look at the X-1 that an awful lot of the information on our drawings has produced something that looks extraordinarily like an M52. Not in detail, because it had a rocket motor and it didn't have escape and things, but the shape.
Well, the Americans went for a rocket motor because they thought that they knew so little about jets. It would take years to develop a jet. They couldn't produce a jet. As it was a rocket, you couldn't take off and fly it because there wasn't enough fuel, so that you had to take it up with an aeroplane and just drop it, and then light the blue paper and...
So it wasn't really an aeroplane, it was a dropped body.
Yeah, flying rocket.
Dropped body.
Yeah, with wings.
Meow.
But the only useful information which they used
I think, was that we were designing and building a supersonic aeroplane, and we were convinced that it would work. And that just drove them on. As if we could do it, they could do it. So that's all they took away. But they didn't understand the rest of the technical information that they had in their briefcase.
In the autumn of 1947, the X-1 was ready to start test flights. The large dried-out lake bed in the Mojave Desert was a huge natural airstrip, and the only place in America where the X-1 could land safely. Test pilot Bob Hoover was assigned to fly the chase plane that supported the X-1.
Chuck was one of the few pilots I really respected and felt was highly qualified to do just about anything.
With each successive flight, Chuck Yeager gradually increased the X-1's speed. A B-29 bomber carried the X-1 aloft, as there was only enough fuel to light up the 4 volatile rockets for a few minutes.
The most critical thing he had was somebody above him cautioning him not to go any faster than some small amount of speed each time. He would have done it a lot sooner if they'd permitted him to do so. But he had to be really disciplined. I'm not sure I would have been that disciplined.
On the 10th of October 1947, Yeager took off on his 8th flight. The aim was to reach 94% of the speed of sound. After the X-1 was dropped from the B-29, Yeager approached the speed of sound. He was flying faster than anyone had flown before. Suddenly, he discovered that the X-1 would not respond to movements of the control yoke. The plane would not climb nor descend.
The sound barrier is a very, very positive thing. It really means that because an aircraft normally in normal flight sends a pressure wave ahead, which opens up the path for it through the air, for it to progress. But as the speed of the aircraft increases and you get near the speed of sound, there is less warning given to cause the pressure waves to break up the air, and they bank up on each other. So eventually you run into what, in effect, is a brick wall. And this causes changes in lift, huge amount of vibration, and a very big change in trim. If it runs away from you, you get into what the Americans so delightfully call a graveyard dive. And there is no way really back from that. The barrier is not just theoretical, it is very, very factual.
To stop the buffeting, Yeager quickly turned off the engines and jettisoned the explosive rocket fuel. As the X-1 slowed down, the aircraft once again responded to movements of the stick. But if the flight control problems could not be solved, Yeager would not be able to fly supersonic. The X-1's tail incorporated a feature to enable the pilot to adjust trim. So far, it had not been utilized in any of the test flights. When activated, it enabled the pilot to trim the aircraft by moving the entire horizontal stabilizer. It was, in effect, an all-moving tail. Bob Hoover recalls a crucial contribution made by Jack Ridley, another member of the X-1 team.
Chuck told him he was beginning to lose elevator control at high speeds. Jack came up with the idea of move the stabilizer up and down to give you more authority on the elevators and angle of attack, so it could hold the nose up. And when that happened, we knew Chuck had a real good chance of getting through it without any problems.
On his 9th flight on October 14th, 1947, Yeager wanted to find out if Jack Ridley's advice to use the trim switch would give him control at speeds approaching Mach 1. If moving the complete horizontal stabilizer still did not give Yeager pitch control, the result could be fatal. Unlike the M.52, there was no provision for pilot escape in the X-1. As As Yeager approached the speed of sound, the X-1 began to buck and pitch. He pushed the yoke forward. Would the all-moving stabilizer bring the X-1 back into level flight? Soon after losing sight of the X-1, the telemetry team heard a loud bang. It was the sound of the first sonic boom.
He went by me, Supersonic, and the reason I knew that, I was in a P-80, and it was an 8/10 Mach number airplane. Well, I remember it very well, very clearly, because I knew it was history being made.
As the needle went off the Mach meter, the buffeting stopped. Beyond the sound barrier, Yeager discovered that air flowed smoothly over the X-1. Yeager had reached Mach 1.06, 700 miles an hour at 14,000 feet, in a flight time of 14 minutes. The sound barrier had finally been broken. When the M.52 team at Miles Aircraft heard that the all-moving stabilizer on the tail was crucial to the success of the X-1, they felt robbed.
Now, the flying tail is the fundamental innovation that the Americans got from us, and which was the thing that made the X-1 the first aircraft to break the sound barrier. Because the X-1 had run into an impassable stage in the tests at a Mach number of 0.94. And of course the flying tail is the one thing that will get you through the compressibility problems in any transonic flight.
But a year before work on the M.52 started, some research on an all-flying tail had already taken place in the United States. Early in 1942, an all-moving tail was tested on a Curtiss XP-42 fighter to see if it improved control in high-speed dives. Up to now, no detailed engineering drawings of the M.52, with its all-flying tail, had been found amongst the Bell X-1 project files. But recently, this rough sketch of the M.52 was discovered in the archives of the Smithsonian Museum. It comes from the notebook of an American intelligence gatherer, Captain John J. Ide.
It's a very rough sketch, probably not more than about an inch or two across, giving brief details of span and weight and stuff like that. And it was dated August 1945, which is rather intriguing because we've got no record of any visits to Miles in August 1945. And we're wondering where he could have got that information from.
2 months earlier, an aerodynamicist working for the Navy by the name of Clark Millikan also visited the Miles factory. His report concluded that the M.52 had little of use for US aircraft designers, and there was no need to obtain additional information from the British government. However, his report did state that the all-moving horizontal tail of the M.52 might be of interest.
So I've always thought that the Americans were behind the cancellation of the M.52 in one way or another, either through pressure on a loan that we desperately needed, or through the fact that they wanted to be the first to break through the sound barrier. But having delved through records of governmental activities, through Hansard and the cabinet meetings, we could find absolutely nothing.
The government established a Supersonic committee to monitor the M.52 project, but it had no representative from Miles Aircraft.
There was no representation from Miles on it. In fact, it was 35 years before we even knew that they had a Supersonic committee meeting every month. And they were just making decisions with actually wrong information. And the minutes of the meeting show that the information that they were talking about was completely wrong on many instances.
In 1944, Ben Lockspicer, the chairman of the Supersonic Committee, asked Barnes Wallis of Vickers Aircraft and Dambuster bouncing bomb fame to become a member.
Having got a foot in the door of the Supersonic Committee, he then very heavily influenced its thinking. And in my opinion, this could have been a severe setback in the progress of the M52 politically. And I think probably was quite a strong contributory factor to the eventual cancellation of the M52 as such.
Barnes-Wallis believed a manned supersonic test aircraft would probably kill its pilot. He proposed a series of unmanned tests using scale models powered by rockets and launched from a Mosquito. The scale models would be built by his company Vickers.
A change, or a psychological change, had occurred to Barnes-Wallis. The famous Dam Busters raid had cost quite a number of casualties, and this preyed on Barnes-Wallis's conscience very heavily indeed. And he had openly stated that he would not now take part in anything that he thought would mean sending a young man out to his death as a pilot or aircrew. And therefore, he promoted on the Supersonic Committee the use of rocket models instead of a full-scale model of the M52. I think his concern about safety was genuine, but I think there was also a strong commercial interest running through all this. And we will never know eventually, of course, but at the end of the day, it had a devastating effect on the M52 as a piloted project.
For 7 years, we, the people of Britain, fought a war for mankind. Today we fight for our own survival. This battle we shall also win.
No doubt we're in a bit of a tough spot, and it'll take a year or two to get out. But we've done it before, and we can do it again.
So why did the government suddenly cancel the M52?
It is a bit of a mystery, but no government minister ever made a comment. It was a socialist government, a sort of in power, if that's the word at the time, that were absolutely dependent on foreign aid. They were absolutely bankrupt over the war.
In addition to saving test pilots' lives, the Supersonic Committee claimed that using rocket-powered models would save money.
No, that was a total red herring. I think at first it was put up as a money-saving project, but of course that did not prove to be the case. In fact, the contrary proved to be the case. Whereas the M52 would probably have cost about $250,000 to complete the project, the Barnes-Wallis project certainly was running into $400,000 to $500,000. So there was quite a difference.
Although Ben Loxposer, the chief scientist, has taken the blame for it all these years, we've discovered that he must have been the mouthpiece, and that the actual cancellation would have been ordered by his boss, which was John Wilmot, the Minister of Supply and Aircraft Production at the time, in order to make cutbacks purely on economic grounds, which turned out to be absolutely ridiculous, but that's the way it appears to have gone.
More than 60 years later, the cancellation of the project, when it was so close to succeeding, continues to irk the M52 team.
Livid, hopping mad, because to me it was utter betrayal. We were not given any prior warning of this decision. We were 82% complete for the first flight when it was cancelled. We had no tricky bits at that stage. The main components were all in place.
And it would have worked, and it would have actually flown, and it would have produced the information we wanted, and our frontline aircraft would have been that much better 2 or 3 years earlier.
I look at it as one of the worst decisions that ever happened in British aviation because it happened at a critical time when we could have been the lead country.
The engine, the W2700, would have been an aft fan engine with reheat. Well, that in itself was a very advanced project, very advanced form of turbojet. It incorporated both turbofan ideas as well as the use of reheat. By cancelling that, which is really peculiar, the government simply turned their back on something that, which of course came along later, done by others. GE were the first to produce an aft fan engine in 1961. Frank Whittle was also working on a front fan axial compressor engine, the LR1, the long-range one, and he'd started work on that in 1943. So really it is a mystery as to why we threw the baby out with the bathwater when we cancelled the LR1 front turbofan and the W2700 aft turbofan. We put ourselves way onto the back burner.
He was angry, we were angry. We couldn't see the reason for it. But it took us some years to realise that it wasn't just technical. There was a lot of political angst in it as well.
The Ministry's explanation never satisfied the M52 designers. The timing of the decision also made the M52 team suspicious. It occurred just 2 months after Frank Whittle resigned as chairman of Powerjets, the company that had developed the jet engine for the M52, and which had recently been nationalised by the government.
The government couldn't cope with Whittle, there's no doubt about that, and to have Miles on top of it, working together, probably they couldn't cope with that either, and it must have been very difficult for the powers. I don't know how they really thought they were going to cope with it, but Miles would have got the job done, there is no doubt about that.
And Whittle, who had been promised he could go on and develop new engines, was broken-hearted, of course, and he naturally became very difficult and fought madly for at least the compensation that would have enabled him to set up another private firm and compete on a legitimate level, but they weren't having that. And they threatened him with everything, loss of pension, being sacked, the works. And then, of course, I suppose some bright spark at the ministry came up with this idea about cancelling the plane so that Whittle could be quietly dropped.
I, as his son, can only say that he could be a bit fierce at times, and maybe he was a bit too fierce with some of these very self-important civilians in the ministry.
Whittle's ambitions for the future of Powerjets had been in conflict with the policy of the Ministry of Supply and Aircraft Production.
Frank's idea was that eventually his company should be able to produce jet engines as well as develop them. The Ministry of Supply begged to differ in this and said that no, that Rolls-Royce would do the production, but he would continue to do the development. And this upset Frank very much, to such an extent that he resigned as the chairman in December 1945 and left the company and took 16 of his top engineers with him. So this, to say the least, upset the Ministry of Supply, or it upset the establishment, if you want to put it that way. And to such a degree that one wonders why the cancellation of the M52 took place just a month later, or more than a month. It just took place in February 1946.
With its Whittle power plant, the fate of the M52 project was locked to that of the engine's inventor.
The sad conclusion that seems now to be accepted that it was cancelled as a rebuff to Sir Frank Whittle for, if you like, bucking the establishment. And one can hardly believe that a project that was going to bring so much prestige to British aviation and to the country as a whole could be cancelled. just to rebuff one man. Not only sad, fantastically nasty.
In 1948, a year after Yeager's historic flight, the M.52 team had its bittersweet moment of glory. A scale model of the M.52 made by Vickers broke the sound barrier. The test demonstrated that the M.52 could have flown at 1,000 miles per hour, 1.5 times the speed of sound. Dennis Bancroft and the M.52 team were vindicated.
From the very earliest days of flying, the county of Berkshire has had a long and enduring connection with aviation. And here, at the Museum of Berkshire Aviation at Woodley, built near the perimeter of the old Woodley Aerodrome, we take a look back over the last 70 years or so. Although the first recorded flight at Woodley was in 1913, the earliest site used regularly for flying was at Coley in Reading, which was used for training wartime pilots for the 1914 war. The build-up of the Royal Air Force in the 1930s saw the establishment of many airfields in Berkshire.
This resembled the typical airfields around 1918. Some had grass runways, while others were paved, and most had a full set of hangars. Within the old boundaries of Berkshire, around 20 airfields were located at sites such as Winkfield, Bray, White Waltham, Cockpole Green, Woodley, Reading, Thiel, Hampstead Norreys, Harwell, Abingdon, Kingston Bagpuys, Shellingford, Watchfield, Membury, Great Shefford, Wilford Grove, Greenham Common, Aldermaston, and even Smith's Lawn at Windsor, which was used during the Great War. By the year 2000, only one airfield, White Waltham, remained, as the others had been overtaken by residential developments and industrial zones.
Okay.
White Waltham, valued by the RAF during the War of 1939, returned to civilian use in 1945. It later housed ML Aviation, known for specialized aircraft equipment, and Ferry Aviation between 1955 and 1965, where aircraft such as Ferry Gannet were produced. A notable example of the Gannet can be seen at the Museum of Berkshire Aviation, displayed just outside the main hangar.
The Gannet was designed to a naval specification, especially for operation from aircraft carriers. I was privileged to fly this aircraft as a pilot in the Fleet Air Arm. It was a delightful aircraft to fly and quite unique in the Navy, in that it had two turboprop engines driving two four-bladed props on a single axis, which obviated the usual asymmetric problems associated with twin engines. It was designed to cruise on one engine, which meant that it was very economical, giving it great range. The aircraft shown here was from 825 Naval Squadron at Culdrose, and I was in fact flying number 342 on that day.
The story of Miles' aircraft began in 1925 at Shoreham, Sussex, when 21-year-old F.G. Miles, along with his younger brother George, began building a biplane based partly on F.G. Miles's design. within part of their family's Star Laundry business premises. However, the aircraft was never completed, as Miles met Cecil Pashley, a skilled aviator, before its finish. The two quickly bonded and were inspired to form a partnership and create a flying school that also offered joyrides in Pashley's Avro 504K on fields known as Eastern's Farm. The Avro 504K, a two-seat World War I trainer with a rotary Gnome engine, was renowned as one of the finest trainers ever made, with over 8,000 units produced. Realizing the risk of operating with only one plane, and despite limited funds, they managed to buy enough spare parts to assemble another 504K after Avro shut down their factory at Hamble. In the photograph, Pashley's plane is on the right, while the partially finished biplane is seen inside the canvas hangar. By 1926, the business was divided, with the newly formed Southern Aircraft Company run by Miles, while Pashley continued operating the flying school. In 1929, Miles designed and constructed his first entirely new aircraft, known as the Southern Martlet, at the new hangar. That same year, Miles piloted its maiden flight, which proved to be an immediate success. A total of 6 Martlets were eventually produced for special client orders. This particular Martlet, featuring a Gannett engine, was built in 1930 and is shown here being flown by F.G. Miles in 1947. One of these aircraft was sold to Maxine Freeman Thomas, the wife of a Southern aircraft director. When Miles and Maxine developed a romantic relationship, Miles found the situation uncomfortable and chose to leave Southern Aircraft, heading to South Africa. He later returned, and after Maxine's divorce, the two married and established a small office in Sevenoaks. Under Miles's guidance, she became an accomplished aircraft designer, and together they developed a small aircraft called the Satyr. Around the same time, in the late 1920s, the company Phillips and Powys operated a car and cycle business in Reading. Charles Powys developed a strong interest in aviation and in 1929 purchased a large field in Woodley, outfitting it with a hangar, workshop, and restaurant while also establishing a flying school. This venture would remain significant for years and continue expanding. It played a crucial role in training numerous RAF pilots, ultimately becoming known as Reading Aerodrome. In 1931, during a cross-country flight in the Satyr, Miles, for reasons unknown, landed at Woodley. When he met Charles Powys, Miles eagerly shared his groundbreaking ideas for future designs, many of which he would achieve during his career.
The Miles Aircraft concern conceived the M39 Libellula during the early 1940s, amid the turmoil of World War II. Initially, the concept aimed to simplify landing aircraft on carrier decks, addressing visibility challenges caused by forward-mounted engines and large wing mainplanes. A novel tandem wing arrangement was pursued to mitigate risks, resulting in a series of concepts explored by Miles during the war. The overarching term for these Miles designs was Libellula, named after the taxonomic family of the dragonfly. The groundwork for this project began with the M35, essentially a technology demonstrator for a single-seat naval fighter. Miles pursued this endeavour independently, using the tandem wing setup to reconfigure the centre of gravity found in conventionally configured military aircraft. In a brief span of 6 weeks, Miles engineers introduced the M35. This aircraft was equipped with a single de Havilland Gypsy Major air-cooled inline engine, boasting 130 horsepower. During testing, the engine exhibited temperamental behaviour and longitudinal control was problematic. Nevertheless, this design provided valuable insights into the unconventional arrangement, contributing to future developments in the field. Building on this knowledge, a new design emerged, scaled at 5/8 and designated as M39B. This single-seat demonstrator featured a pair of de Havilland Gypsy Major IC air-cooled inline engines, each with 130 horsepower, showcased in outboard nacelles beneath the rear wing mainplanes. The frontal mainplane was now positioned low against the sides of the cockpit, and the fuselage boasted a finely contoured shape from nose to tail. The undercarriage transitioned to a traditional tricycle configuration. Given the larger scope of the M39B project, its dimensions were appropriately increased. The wingspans now measured 25 feet at the front set and 37.5 feet at the rear. The overall length extended to 22.3 feet, and the maximum weight rose to 3,200 pounds. As constructed and tested, the M39B achieved speeds of up to 166 miles per hour thanks to its twin-engine setup and tandem wing approach. The maiden flight for the M39B occurred on July 22, 1943. A dorsal fin was later fitted at the fuselage aft for additional control to complete the M39B's iconic three-finned appearance. Up until September of 1943, all of the work on the two aircraft, M35 and M39B, was as a private venture. From then on, the British Air Ministry decided to offer a formal development contract to Miles. Shortly after, Miles sought interest from the United States Army Air Forces, aware of their consideration of the domestic Curtiss XP-55 Ascender, which shared a tandem wing pusher engine configuration and was intended as a fighter. The USAF's response revealed a general lack of interest in the Miles product, as the XP-55 itself faced issues, particularly with stalls and recovery. The American program only progressed to flight testing, producing 3 aircraft in total. The M39B underwent evaluation at the Royal Aircraft Establishment, encountering problems from the outset. A new undercarriage had to be installed, and several accidents necessitated constant repairs, keeping the aircraft grounded for extended periods. Despite its unconventional arrangement, overall handling characteristics were considered normal. While landing and takeoff required adjustments to the standard routine, these were deemed forgivable, and stalling and recovery performed as anticipated. In 1941, the RAF issued a new specification for a medium-class, medium to high-altitude, high-performance bomber. Miles responded with its M39 project, a modified version of the M39B featuring a pressurized cockpit for a crew of 3. The proposed power for the M39 project included either 2 Rolls-Royce Merlin 61 series inline engines or 3 Powerjets W2500 gas-powered turbine engines. This design featured a significant wingspan increase, measuring 37.5 feet at the frontal wing and 55.8 feet at the rear pairing. The overall length expanded to 35.9 feet, and the maximum weight surged to 26,750 pounds. The envisioned cruising speed was 360 miles per hour, and armament was planned to include 2 20mm cannons in the wing roots, 1 gun per root, along with an internal bomb bay in the fuselage, capable of carrying up to 6,000 pounds of bombs. Ultimately, the de Havilland DH-99 Vampire fulfilled the specified requirements. The Hawker P1005 also competed for a period. Although a prototype M39 high-speed bomber was ordered under a November 1943 contract, it was never constructed. The RAF's bomber needs were met elsewhere, leading to the termination of the M39 project, along with the data-collecting M39B aircraft. While surviving the war, the M39B lasted only until 1948, when it was scrapped. Despite its shortcomings, the Miles Libellula left an indelible mark on aviation history. Its bold, unconventional design inspired future aircraft engineers to think outside the box and take risks. The Libellula remains a testament to the power of human ingenuity and the boundless potential of innovation. The Miles M39B Libellula serves as a fascinating case study of a daring, experimental aircraft that ultimately fell short of expectations. Its unique design, ambitious goals, and ultimate cancellation offer valuable lessons for future aviation endeavours.
Every aircraft has a story that deserves to be told. Don't let these legends fade into the past. Like this video and subscribe to our channel and help us keep aviation history alive.
Between 1942 and 1946, top-secret development was undertaken on the British supersonic aircraft, the M.52. This bullet-shaped plane with razor-sharp wings was designed to fly at an incredible speed of 1,000 miles per hour. Design of the M.52 took place at Miles Aircraft Limited, an aeroplane manufacturer known for aircraft like the Miles Messenger, the Miles Master, and the Miles Martinet. The company was headed by the unique duo of brothers, Fred and George Miles, with the help of Fred's wife, Blossom.
Both Freddie and George had that streak of innovation. I think really this was the hallmark of everything that happened at Miles. And Blossom, I think, sometimes just tempered them down to reality now and then.
George Miles, the chief technical director and designer at Miles Aircraft, was known for highly imaginative designs like the tandem wing M39 Libellula, an experimental aircraft meant to meet the Air Ministry's specifications for a high-speed and altitude bomber. In 1944, George Miles came up with the idea of creating an inexpensive, multi-purpose aircraft, which could be used as a military freighter on unprepared airfields or as an air ambulance or flying hospital in the Burma campaign. He recognized that such a transport would be a hot commodity in the civilian market when World War II came to a close. This aircraft would be known as the Aerovan.
Well, just towards the end of the war, there was obviously a lot of concentration on the transition from military projects to civilian aircraft. And my uncle George had a very imaginative approach to aeroplane design, and he reckoned that a small one-ton freighter would be needed all over the world for carrying loads by air, the sort of things that are carried by one-ton trucks by road.
The twin-engined aircraft with tricycle landing gear was largely made of wood. There was a single wooden spar, and the pod-like fuselage was made of plastic bonded plywood. At the back of the plane, the large hinged door and high tail made the Aerovan easy to load and unload. The interior of the pod could be configured in a number of ways depending on the end use of the Aerovan.
The Aerovan was designed with this pod-type fuselage to be a multi-purpose aircraft. You could equip it with seats and turn it into a 12-seater passenger aeroplane. Take the seats out and it becomes a one-ton freighter. You could drive a car into it and use it as a car transporter, or it could take just ordinary freight in packing cases.
One of the innovative features of the Aerovan was how low it was to the ground.